Hybrids. Now, coming to the challenges and limitations of reinforcement learning when applied to the robotics world. One of the important challenges we do face is the sample inefficiency. The requirement is very huge. The number of samples required is very huge for training, but that number of samples will not be available. That's one problem. The other problem is when working with a large number of samples and making the training process in real time, it becomes difficult. So working in real time will be difficult. Getting the sufficient samples is difficult. The real time problem is maybe because of the availability of the samples, maybe because of the actuator delays and many more issues. So for better policy building, we require millions of interactions and getting those number of interactions, getting those number of samples is definitely a difficult task. And during the real-time execution, the wear and tear or mechanical failures on the way will definitely hinder our activity, and this will have a severe problem when working on real-time basis. The next challenge we do face is converting the policies from the simulation world to the real world. There is a huge gap. In simulation world, mostly we deal with the ideal situations, and even if we try to include the reality, it may not be exactly possible or all possible situations in the real sense cannot be included, and hence simulation is still almost an idealistic issue. But when it comes to real time, then the most of the unforeseen situations can come when we are working on real situation, real world actions, and we do have challenge while converting the policies from the real simulation to the real world. Simulations are morely on the ideal situations. So even if we have a perfect simulation, uh, having a perfect simulation of the real world is impossible, and therefore the training process will never be complete unless until it really works in the real world situations. And hence, whatever training is done during simulation is not sufficient. And the robots may act unpredictably or dangerously after the transfer because of unforeseen situations. The robots may act unpredictably, and because of some faults during the training, which we had never foreseen, because during training, mostly the practical situations are not possible to foresee all possible things. Therefore, some possible situations might not be considered during the training, and unfortunately, if such situation comes in real time, then we cannot predict what could happen, and the act may be unpredictable or even can be dangerous after we transfer to the real world situation. Of course, there are many limitations with the hardware, like the power, sensors, actuators, and many more. So, when we are working on any robotic system, we do face the problem of the power because in remote areas, getting the electric power is difficult. So, we need to depend on the battery power or any other mechanical power, and this will be a lot of limitations we do face. Sensors, we may not always get in a perfect way. The sensors we require may not be always available. The type of the sensor or the other issues with the sensors have to be dealt properly, but we may get difficulty in having proper sensors. And once we have sensors, then we have problems with the noise and eliminating of the noise and all that. So a lot of hardware required, but everything may not be available and may become a challenge and a limitation for our robotic system. Now, coming to the future direction where we stand, we have seen now if we want to foresee where we can proceed further in future. So we can think of working with multi-agent reinforcement learning where we have multiple robotic systems which work in collaboration. So here we can extend a single agent reinforcement learning to environments where multiple agents interact, cooperate, or compete with each other. So we can think of building such a system. Here, each agent learns a policy to maximize its cumulative reward instead of its own reward. So overall, the reward of all the agents together cumulatively, each agent is striving to achieve highest possible cumulative reward. So looking at applications of this multi-agent reinforcement learning, we can work with drone swarms. So here, the multiple drones can be made to work in unison for some specific task in a coordinated way so that they can be used for coordinated search and rescue missions, can be used for factory robots, cumulative assembly lines where robots share the task and they work uh, through interaction and cooperatively they work. And about the autonomous vehicles, so the each of the vehicle on the traffic will coordinate with each other as a multi-agent reinforcement learning system. And here they move in cooperative sense, interact with each other, and move in cooperative way so that there won't be any accident and any such things that could disturb the system. So the other side, we can think of neuron symbolic integration. So we can think of integrating the neural system. So here we try to combine the neural networks like data-driven learning with symbolic AI, that is rule-based reasoning. So one side we have data-based learning. We are having the data, and this data is fed to the neural network to learn. And on the other side, we have rule-based reasoning. So these two are integrated together to create a system that will leverage both perception as well as logic. So the neural network system is a logical world, whereas the rule-based reasoning is perceptive. So combination of these two can be used to make it more realistic, like a human version. So this type of thing can be useful in task planning. So neural network robot uses a neural network to recognize objects and a symbolic planner to sequence the actions. Safety constraints so is used to encode rules symbolically while using the reinforcement learning for adaptive navigation. Then explainability, the symbolic systems provide interpretable decision traces for debugging. So it can provide some debugging decision traces which can be interpreted by the humans. So why such an action is taken. So it can provide a explanation. So finally, to conclude, we in this series have achieved many things. So the key achievements we can see is about the adaptability, is about the autonomy. Then we build the system under simulation and then transfer to the real world system. We can think of multi-agent coordination, and there are still challenges remaining. That is about the sample inefficiency. Still, we are not happy with the available samples, the size of the samples that can create a system. So there is still sample inefficiency is still persisting. Safety and robustness, we are still not up to the mark. We are still not happy with whatever safety measures are being implemented. So the challenge of safety is still persisting. So work has to continue in this direction, and robustness is still yet to achieve. It is still working for a even particular task, but we want to make it a more generalized situation, making it more robust. The work is still to be taken up. Yes, reward system design is still in a early stage. It has to be improved and to have a better reward system, we need to look into more detailed design, how better the reward system can be created so that the overall learning system is more efficient. Then these hardware limitations still persist. So new technology is being awaited. So we can overcome these hardware limitations. Future directions, we can think of hybrid architectures, meta learning, human in the loop reinforcement learning, and the important thing is ethical and safe reinforcement learning. What are the impacts on the industry and research in the manufacturing? Yes, of course, robotics is going to contribute a lot, and it's going to make precision manufacturing faster manufacturing. It can speed up, it can have provide a high precision, and in healthcare, of course, a lot of expectations are there in the healthcare. So we can make a robot to do the surgery. Here, uh, precision, accuracy, and all that can be improved provided a robot is properly trained for doing an operation on any human or any ailment. Of course, in space exploration, where every time human cannot go, so unmanned exploration is still uh, what we can achieve. So the when we are looking for unmanned exploration, resting would be robotic activities to be used to whether it is to release what we can say. So this space exploration, so it can be any vehicle maneuvering on any surface like Mars or Moon or any other thing. So it can be unmanned and sitting on Earth, we can control them. So a lot of possibilities are still there, and it's required to continue. So final takeaway, what we have in this whole series is reinforcement learning is not just a silver bullet, but yes, still it's a powerful tool in our robotics toolkit, and its success hinges on bridging the gap between the simulation and reality. It's a big uh, what we can say is challenge still we have. So if we can take up this, yes, we can make a wonderful thing, balancing the exploration with safety. So we must ensure that the exploration actions are taken up in safe environment. So how that can be done, we need to look at and integrating the domain knowledge like physics or human expertise and all that with our robotic system is equally important when it comes to creating a robotic system under artificial intelligence. So the future of robotics lies at the intersection of reinforcement learning, neuroscience, and ethics. So we need to work on the reinforcement learning. We need to work on neuroscience and ensure that ethical issues are considered while designing any robotic system. And here the machines not only learn to act, but also we must ensure that they act responsibly. So, how to act is what we make use through reinforcement learning. But to create that reinforcement learning system more efficient, we need to understand how we work. So for that, neuroscience is required, and to make sure that the technology, whatever we are talking about, is not going to harm the system, harm the environment, harm the humanity. There should be ethical side of it. There should be ethics to be properly enforced, and therefore, it's not just creating a machine which can learn just to act, but also should act more responsibly. So that's what we can see in our future robotic world coming very soon. So that's it for now. Thank you for all your support. So more queries, any queries are there, can just follow me on these email IDs, and you can follow all these lectures on my YouTube channel provided here. So thank you. Thanks a lot.